So I got my force of gravity down on all three elevators. I got my normal force up from the scale on all three elevators. All right, next thing we're going to do is real quick, we're going to solve for the force of gravity, what the value for gravity is. So that's going to be Fg equals mg. Mass is, what do we say, 61. G is 9.8. Someone solve that for me real quick. Just do 9.8 times 61. Tell me what you get. What you got, Jacob? 597.8. Excellent. Thank you. Confirmed by another source. 597.8. Okay, so that is the value for gravity. Here's what I want to know. In what direction should the net force be in all the situations? So that's the first thing I want to know. And the second thing I want to know is going to be, what does that say about the forces here? So I'm going to break this into three parts. And all you have to do is tell me, is the net force up? Is the net force down? Or is the net force 0? And then you're going to break number 4 into three parts. And for that, I just need to know, are the forces equal? Is normal greater? Or is gravity greater? So we're basically going to set them up and say on this one, so what you want to do is, with your partner, decide which direction is the net force, up, down, or 0, for each of these three scenarios, and which one is larger, or are they equal? Is the normal force larger in the first scenario, or is gravity, or are they the same? Is normal bigger, gravity, or the same? That's what you want to do. So go ahead and, as a team, decide 0. All right, good. Net force is 0 if you're at rest there in the elevator. Nasir, what about the second one? So if you're accelerating up, what direction do you think the net force is? It is up. All right, and Joshua, what about that last one? If you're accelerating down, what do you think the direction the net force is? Down. Yep. Excellent job. You guys figured it out. The net force is the same as the acceleration, directionally. Okay? So if the acceleration is 0, the net force is 0. If the acceleration is up, net force is up. Acceleration down, net force is down. Good. All right. So now we need to figure out what's going on between the force of gravity and the normal force. So if we know that the force is 0, the net force is 0, then, Evan, what does that tell me about normal force and gravity? Yes, they are equal to each other. If the net force is 0, those forces are always going to be equal. Always. That's a very helpful thing when you're solving problems to just keep in mind. Okay? Lucian, what about when the normal force, what about when the net force is up? Which one is going to be larger, or are they the same? What makes you say Fg is larger?
Because the elevator is going up, he wants to continue going down.
You're thinking inertia. That's a good thing to think about. However, there has to be a force to keep him from doing that, to actually make him change. And that means the force is going to be up, and the up force is normal. So good thought, but it's going to be the normal force that's larger here. And that's because the normal force is the one that acts up. Right? If the net force is up, what force is up? Normal. So that means normal is the larger one. All right? Davin, what about that last one? So if the net force is down, is gravity larger, normal force larger, or are they the same?
Gravity. Well, yes, gravity would be larger.
Okay. What makes you say that?
Because
Yes. And the acceleration is down, the net force is down, so the down force is the larger force. It is gravity. Good. So, here's the funny thing. If you were to stand on an elevator and you were to accelerate down, you would actually weigh less than you would normally. And you would feel like you weigh less. And that's actually what you would see on the scale. Now, do you actually weigh less? No. But you don't actually know what you feel like. You just know what gravity acts on, or sorry, you just know what the normal force acts on you with.